Hello everyone, welcome to another video. Today we're looking at the derivative of the function y equals e to the x. Um, Now, just a thing about e to the x. So we can look at the graph of y equals 2 to the power x, right? And if you remember what the graph of 2 to the power x looks like, it'll sort of go through 1 on the y-axis, and it will sort of grow up exponentially. That's what we're talking about when to the power of x. We've got graphs that grow up exponentially. So that would be sort of like the graph of y equals 2 to the x. Now, there exists a number called e, and it's called Euler's number. It's a constant, so it's just a number. So there exists a number where y equals e to the power x. There's some number e where when you sketch the graph of it, every single point on that line, so every single point, if I pick a point, like say there, that green point there, where the gradient at that point, will be exactly equal to its y value. So here, like say, we'll say gradient, I'm just like going to throw a number at it, right? If the gradient there is equal to, let's say it's 2, then the y value will be 2. So let's just say it's 3, 2, whatever. It doesn't look like that. I've done a bad number, no, that doesn't matter. So the y value is the same as the gradient. And so if I pick another point here, and maybe the gradient there is equal to 1, then the y value there will be 1, okay? So what I'm saying is that there exists some number e where the gradient at every point on the line is equal to its y value. In other words, dy dx is equal to the y value. Okay, and this brings up an interesting situation. And what actually happens is that we said before that y is equal to e to the x. There exists some number e where that is true. And so if we put that back into the equation, dy dx is equal to y, that's actually equal to e to the x. And so what that means is that means the derivative of this function is actually itself. Okay, so there exists some number e where the derivative of that function e to the x will be equal to e to the x. So the derivative is equal to the original function. And so that number e is known as Euler's number. And it's Euler's number is roughly equal to 2.718, blah, 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 blah. It's an irrational number. So it has infinite non-recurring decimal places. And that's what we have there. So it's a really interesting number. It occurs in nature a lot, and it's like considered to be, I guess, like perfect exponential growth that happens in nature. It comes up in finance with like compound interest, with how that grows over time as well, and etc. So that's just a really quick idea about what E is. And so the long shot of it is that the derivative of y equals e of x. Derivative is just e to the power x. It does not change. Okay, fantastic. So let's have a look at a couple of questions to sort of solidify that. Okay, so let's have a look at this. Y is equal to 2e to the 3x plus 1/3 e to the negative x over 2. Okay, so let's go straight into the derivative. So dy dx equals, right. So with this first one, we've got 2e to the 3x, and I might just go back a little bit. I probably didn't quickly talk about that. So I'll just do a quick little table here. Maybe I'll do it in green so it doesn't sort of muck up everything. So let's just do a quick little table of some things. So just to remind us before we sort of go. So e to the x, the derivative is e to the x. If you've got e to the kx, so e to the constant times a number, then that constant will come down the front and multiplied by that function. So that constant, that's just the chain rule. That constant will come down the front. And also if you've got e and with some function, g of x, if you've got like a whole function up in the power, then the derivative of that power comes down the front, and then everything else just stays the same. Okay, so e to the power of some function of x, the derivative of that function of x comes down the front, and then e to the gx just stays the same. So Sorry about forgetting to sort of go through a couple of those things, but let's have a look at this first one. So the first one, there's a constant sitting up in the power, and so that constant just comes down the front. And so that just becomes 2 times 3, that 3 comes down the front, e to the 3x. That just stays the same as per this rule over here. And so we've got that bit's sort of done. Plus, there's 1/3, that 1/3 just stays out the front. And then what's the constant that's sitting out the front of x here? That's -1/2. -1/2 that's sitting out the front of that. And so that -1/2 comes out here. And then everything else just stays the same. No change with the e part to it. If we just tidy that up, 2 times 3, that's just 6e to the 3x. And tidy that last bit up. Double x, right? And then minus 1/6 e to the -x over 2. Okay, so the powers, if the constants just pop down the front, nice and easy for that one. Okay, let's have a look at another. If you've got something that looks like this, we'll be looking at a quotient rule to be able to deal with things like this. But for now, what we're just going to do is just divide through by e to the x. Okay, so before I find the derivative, I'm just going to divide through. So it's going to be 4e to the x over e to the x, just dividing everything by e to the x, minus e to the -x over e to the x, plus 1 over e to the x. So just dividing each term by that. I'll just save myself a little bit of space. I'll come over here. So that cancels out with that. So that's just 4 minus e, and then it's -x. -x take away x because we've got a fraction there. So that would be -2x. Subtracting the powers there. And that's just plus e to the -x, because that's e to the x is on the bottom line, so that's just a negative power. So I've just rewritten f of x in a different format. So now we can take the derivative. So f dash of x, the derivative is equal to the derivative of 4. 4 is just a constant, a number, so the derivative is 0, so that just disappears. For e to the -2x here, this one here, so just remember that -2 will come down the front and multiply by that. I'm going to skip a step here, so -2 times -1 will just be +2, e to the -2x, okay? And then that last one there, what's the derivative of that one? The derivative, that -1 will come down the front, and so it will just become minus e to the -x. And that's it, okay? So just a reminder that -2 came down the front, and that became -2 times -1 to make +2. And this here, the -1 came down the front, okay? And then everything else just stayed the same. So that's how we cleaned up that one, okay? So that is done, that's the answer. In case I didn't make that clear. So last one for this video, we've got e to the, there's a function inside the e, okay? So not just numbers or anything like that, or constants in front of x, we've actually got a function, so I need to apply this pattern here. So anytime we've got e to the power with a function of x, the derivative of the function comes down the front, multiplied by e to the gx. So let's have a squiz at this, okay? So I'm not going to do any rearranging of anything, so I'm just going to go straight to dy dx. And let's do this. The -2 just sits there, so let's just put him there, and I might just put him in brackets there. Firstly, we need to put the derivative of this bit down the front, okay? So bringing that down, the derivative of that down the front. So here we go. The derivative of 2x squared is 4x. And the derivative of 3x is +3. The derivative of -2 is 0, so it doesn't come down the front at all. And then we leave everything else as the power. It doesn't change. Remember, this e to this power of whatever does not change. So that sits there like that, and that's it. And then this last bit here, this +2e, just remember e is a number. So 2e is also a number. The derivative of a number is equal to 0. You know that. And so that just goes away. Nothing happens at all. Nice and simple. And so let's just clean this up. So this is equal to, I'll just bring this all out down here as -8x minus 6 e to the 2x squared plus 3x minus 2. That's all we're going to do this video. Hope that all made sense. See you in the next video.